Let's get some basic understanding of working of a human eye. So the basic job is it converts light into electrical signal, and this is sent to the brain, and brain understands and we understand, and so on and so forth. So that's the basic of any eye, to be frank, not only human eye. So the eye changes the rays, that is a light rays, visible light rays to be specific, into electrical signal, and these signals are then sent to the brain, which interprets them as visual images. Okay, so this is visible light rays, to be more specific. So the parts of human eye are, there are 9 of it, which we are learning, and the respective functioning is over here. I put it in the most simplest manner. Of course, the detail of it will not be learning, only around 9 of it, right? The parts and their respective functions. So we'll begin with cornea. It's the transparent part which we pretty much can't see. I mean, it's the point of being transparent. So if you observe carefully, we can see the cornea. So it is the frontmost part of the eye. So it's transparent. It is one which protects the eye. Okay, it's one of the part of the eye which protects and also focuses the light. So there are dual functions to it. Then we have iris. So iris is that part. So this is one, by the way. The iris is the part which we call it as color of the eye, so-called color of the eye. See, basically when you look at a person's eye, we see the white part and blue or green or brown or black part of the eye, is it not? So that is your iris. So iris is the one which controls the amount of the light going in. Why should it control and how does it control? We'll understand that in a bit of time. Between the space of 1 and 2, so this is your iris, by the way, we have some jelly-like material. Oh, so this is 3, sorry. Jelly-like material between these two space. That functioning and stuff I won't be explaining, and I won't be pronouncing it as well because I don't know how to pronounce this name. So we have something called as pupil. This is something related to iris that I'll tell in time. Next is the lens. So lens is over here. This lens, as you can see, it looks like convex. So it is to converge the light from the object onto the retina. Retina is the one which has the sensors which converts the light into electrical signal. Okay, so these are your retina. I mean, that's where the retina are, not that. That's where the retina happens to be. And we have optical nerve which carries the signal from the eye to the brain. So I have missed out. Okay, ciliary muscle. Ciliary muscle it deals with lens. Okay, what part of lens and how does it handle lens and why does it handle lens? So that you will understand in time. Okay, so then we have again one more name which I can't pronounce. So the 7th one is again a jelly material like the second one, which is a bit in this space, in this empty space. Okay, so I think I pretty much covered everything, right, on a brief note. So this is the transparent part which protects and focuses the light. Then iris controls the amount of light that I'll be talking. Lens also I'll be talking in detail. Retina is the one which has the sensors. It converts the light to electrical signal, right? So let's look into iris. So the role of iris is quite simple. See, we have seen this particular experiment, is it not? If not, this is one of the questions which I have dealt with, and this is the experiment related to that. So I have a convex lens, entire lens, and this is the image. So this is the image related to this particular setup. So in this, the lens has been covered, half of it has been covered, and the same image is seen, just that the intensity is less. It's not that bright. In the most simplest manner, it's not that bright. Reason being, it's been covered. So if we cover a lens, we get the entire image, just that the brightness will be less. Okay, does it make sense? So that's what our iris does. It controls the amount of light. So in darker space, right, where there is less light in the surrounding, it opens up a lot. Okay, so that whatever minimum amount of light the space has, that can go into the eye, right? And in very bright space, in a bright region, it becomes small because too much of light into the eye, it can hurt our retina. So it closes up, letting in sufficient light. See, the point of both is letting in sufficient amount of light. How can you do that? Here you reduce the amount of, basically the space. Okay, so this is opaque and this is transparent. So the middle part is transparent. So this which I'm shading is transparent, and this colored one, the brown one, is opaque and transparent. So the intensity of light going into the eye tries to be constant. How will we control it? Well, letting in more light in the sense same amount of light, but opening up, because the space is dark, there's already less light. And over here you make it smaller because there's sufficient bright light, and so your iris, it kind of closes up, letting sufficient light so that our eye can make sense out of it. Okay, this is the whole working of iris. A brief, we're not going into the detail, just a brief part. Now I'll talk about all of this once more with the help of 3D model. So this is an amateur 3D model, so please don't take it seriously. So this is your optical nerve. Again, this is just an amateur setup so that it's easy to discuss, that's it. So this is your optical nerve, first thing. Connecting to that is your retina, which has an empty space kind of thing. Okay, so in this is that liquid, jelly liquid, that V, it starts with V, right? I don't want to pronounce that, it kind of sounds funny. So it has that liquid in this space, and the retinas are in this, on the wall. Okay, so sensors and everything are on the wall, and that is, all of it is connected to the nerve thingy, nerve path, and that is connected to your brain. Okay, so in this empty space I have placed a lens. So this is a transparent lens, obviously convex, so that we get a real image on the eye, retina. So okay, that's not it, sorry. And we have the iris. This is our iris. So I told pupil, I'll tell later. Pupil is this space, this empty space that the iris has opened up. That empty space is pupil. So this scenario is where do you think, brighter space or dark space? This is a small region. It's for bright space. Why? Because there's already enough intensity of light. The amount of light going in is to be controlled. So I want to reduce the overall, it has to be the same. So there is enough light out, so I can make it small. I mean, it happens automatically, but in a dark space. Okay, so let me show it to you. So in very dark space, what happens is it opens up a lot, right? So that more light can go into the eye. Can you see that? So this is the back part of the eye. Okay, does it make sense? So this empty space, absence of iris, or this region is your pupil, and this brown thing, and for some people it will be green as well, I guess. I hope that's a possibility. Then bluish. Okay, I am just guessing. Brown is something, yes, which is common. Blue, I think it's there. Green is also kind of there, I guess. Red, okay, I forgot. Maybe it's there. You guys can tell me if you guys have a different iris color, People are fascinated with different eye colors. Okay, then you have cornea. So again, that's a transparent one. So yeah, it has it protects from dust and everything. So I made it thoda dusty. Okay, this is also transparent again, obviously it has to be. So this controls the amount of light. Okay, does not control the amount of light, it helps in protection. Okay, that's one of the basic functioning. And holding all of this in place and giving it a structure and protecting it is our SCLERA, sclera. Hopefully I pronounced it right. The white one is called as sclera. Okay, so how do you think I have done with this model? I mean, I just did it in I think 20 minutes. Do you guys liked it? Let me know. So yeah, this is the entire thing. Okay, right, so you guys need to draw all of this and do all of it. And one last thing, the physics part of it, I can't obviously leave. Whatever subject it is, every subject is interconnected, that is there, but I would like to talk about the physics part, the math and the physics part. So this is your principal axis for this lens. So now if I have an object over here, what happens? The light from this, infinite rays goes out. Okay, so this is not, our iris is not letting that in. So something like this. Okay, that's not happening. I don't know why. Yeah. So okay, it's going to the blind spot there, you can't see. Let me take an object which is smaller. Okay, so we have a parallel beam of light. Say the focus is somewhere over there. Might be there or might not be there. Yeah. And through optical center, yes, the image is formed over there. Okay, so this is the basic working. That's it. Got it? So basically this is how the entire thing works. So say this is very bright. So what happens is light will be there, but iris will protect our eye, retina, from letting in a lot of beam of rays, So this is how iris work. So this space, empty space, is our pupil. I hope you guys are able to link everything. So all the things over here, rod and cone, they're called as rod and cones. They trigger over here and signals and everything, and they start traveling in matter of fraction of second. That's kind of amazing now. Anyways, so we have the labeling over here. So I can't talk much about it. I mean, it's fascinating, but my knowledge is limited. So this is your write-up. So please do write. Try to draw. I mean, this is the rough version. So don't make don't spoil it more than this. It's already spoiled enough. So try to draw this and write all of it. Okay. So pause and have a go. Let me change it to amount of, controls the amount of light. I think I've written it over there. Iris, amount of light. Okay, let me make it a bit more specific. Controls the amount of light going in.